All right, number 6. Given a string, find the length of the longest substring with all distinct characters. So what we're trying to find in this problem, we just want to find the longest substring where we have all unique characters. So if we were to start here, we have A, B, C, which are all unique, and then we get A, and then we would have to move that down, and then if we added B again, we would have that. So then we would need all new unique characters there, and so forth. And then it would be, so these would be all the substrings within this string that have unique characters, and so we can see in the beginning here that 3 is the longest substring that we get that has all unique characters. So for the solution for this problem, I'm going to be using a hash set, and I'll have my string. And then we're going to have 2 pointers, I and J, and they're going to start at the beginning. And we're going to have a max that will initialize at 0. And this is what we're going to be returning, is this number here. And so what we're going to do is we're going to be using J to add the characters at J, and then we'll go down the line, and once we hit a character that I is at, then we'll remove it from the hash set and then bring I down. And at the end of it, we should be able to find the maximum set that was within that hash set. So we can start off, so while we're going down the length of this string, if hash set doesn't contain character at J, and so since we're just starting, we don't have A, so we will add that. And then we'll move J down. And then we have 1 in our hash set, which is larger than 0, so we're going to update this max to include that. And so now J is at B, which we don't have in here, so I'll add that. Now we have 2, so I'll put that in there. So now J at C, we don't have that in our set, so I'll add that, and then update the max, and then move J down. And now J is at A, which we do have A in our hash set, so what we're going to do is we're going to remove what we have at I. So we'll remove A, and then we'll move I down. And so now J is pointing at A, which we don't have in here, so we'll add that in. And then move. And we still only have 3, so our max doesn't add at that. And so now J is at B. So we have B, so we're going to remove what we have at I, which is B. Then we'll move I down. So now J is at B, which we don't have, so we'll add that in there. And we still don't have a number larger than 3. So now J at C, which we have, so we'll remove what we have at I, which is C. Move that down. Now we no longer have C, so we will add that back in. Alright, so now J is at B. We have B, so we remove what we have at I, which is A. And then we move I down. So now J is at B, and so we have to remove I has B, so we'll take that out. And then we'll move that down. Now J is pointing to B, which we don't have, so we'll add that. And then we'll move J down. So now we have j at b, which is in our hash set, so we remove what we have at I, and then we move I down. Now we have b, so we got to remove what we have at I. We'll move I down. Now j is at b, we don't have it, so we'll add that. And so now we're at the end of our array, and we return the max, which we never got larger than 3, so our answer to this problem is 3. And then the time complexity is O of n, since we're just going down this once. And then the space complexity isn't quite O of n because we're not adding everything in at once. In this case, we only got larger than 3, so it's kind of somewhere in between O of 1 and O of n.